In this section, we're going to be looking at the side-side-side congruence postulate, otherwise shorthand way known as SSS triangle congruence. We're given that KL and NL are congruent. We're also given that KM and NM are congruent, and we want to prove that triangle KLM and triangle NLM are congruent. So if you look, we have KLM and we have NLM, and if you notice, when I go around, we're going in the same order. We go from one tick mark to no tick marks to two tick marks. And on the other one for NLM, 1 to none to 2 tick marks. The thing you need to notice here in this problem is that the LM that is a part of KLM is also the LM that is a part of NLM. So therefore, the two triangles will be congruent by the side-side-side congruence postulate. We have one set of sides, two sets of sides, three sets of sides congruent. So in the proof, and this is written out just sort of informally, we are given that these things are true. We know by the reflexive property that LM is congruent to LM, and by the side-side-side congruence postulate, we know the two triangles are congruent. In this second section and the second example and all the other ones that are going to be after this, we just want to know if the congruent statement is true, and to explain our reasonings, we'll explain all of these by side-side-side. So if we look, we can see DG and HK are congruent, DF and HJ are congruent, and then FG and JK are congruent. So if you look, it says DFG, that goes from 2 to 3 to 1 tick mark, and HJK goes from 2 to 3 to 1 tick mark. So these are written in the correct order, and the two triangles would be congruent by side-side-side. So three sides of one triangle are congruent to three sides of the second triangle, and the two triangles are congruent. Alright. So we want to know if this statement is true as well. If we look, and we can mark the figure, we can see that AD is congruent to BC. We also know that AC is congruent to AC, but AB is not congruent to CD. Therefore, this statement is false because we need all three sets of corresponding sides to be congruent, and we know AB is not equal to CD. Therefore, the two triangles are not congruent. And again, we're given that BC and AD are congruent. We want to prove those are congruent. Again, we know BC and AD are congruent, AC and AC are congruent, but AB is not congruent to CD. Therefore, the statement's false, and the two triangles are not congruent. For this third one, very similar to the last two examples, we can see that QT is congruent to TR, PQ is congruent to SR, and PT is congruent to TS. And we look here and it says QPT, which goes from 2 to 3 to 1. RST goes from 2 to 3 to 1. So again, the two triangles will be congruent here by side-side-side. Okay? And that's it for this one. Thank you.